Okay, well, thanks a lot for the invitation. I don't have a formal presentation, so I will save you time. Hopefully, I can pass the message through. My name is Federico Trucco. I'm currently the CEO of a company called Bioceres, a company that is the product of an initiative led also by former Minister Barañao here now, also present in the meeting. That started back in 2001 at the peak of the Argentine debacle, when a group of farmers that have, in a way, experienced the impact of biotech in agriculture. If you were Argentine, you would know what biotech means due to a crop called soybeans that in '96 introduced biotechnology to the broader population of the country, because that is when we started planting Roundup Ready soybeans, and when that crop sort of took off, and today explains 50% of what we export from the agricultural sector. No? So that had a dramatic impact, and that one event, that one technology that sort of opened up the eyes of farmers in Argentina was originated overseas. And back in 2001, at the peak of the debacle, we thought that we were going to have difficulties on a forward-going basis remaining attractive to these international opportunities. So that is when this group of local farmers decided to chip in some money and infiltrate the local academic system with a very naive understanding around science and what it would take to transform pre-competitive research into products, and started funding some local initiatives in a space that we today know to be sort of the biggest opportunity in the ag input sector. So back in 2001, the companies that led ag inputs or biotech-derived ag inputs were companies known by having developed very successfully technologies that we call binary technologies. These are technologies that can be used to either kill or not kill a living organism, an insecticide, a fungicide, a herbicide, or biotech events that allow you to use any of these products were introduced into major crops. And these technologies are very clean, they're white or black, and they help us develop a $20 billion industries. What we didn't know then, and we know today, is the biggest opportunity in terms of crop productivity and capturing the photosynthesis that is performed in agroecosystems is not around improving the ability of plants to compete with other living organisms, but is around improving the ability of plants to deal with non-living things, weather events, climate change. If you think from a scientific perspective or stoichiometric perspective, what limits photosynthesis or productivity is the availability of water, no? And we have to combine CO2 with water in the presence of light to get sugars and oxygen. There's plenty of CO2 in the atmosphere, there's plenty of light. The rate-limiting reagent is water. So that is what we decided to do then, tackle that stoichiometric limitation to yield, and we were very lucky to meet a scientific group locally that took a very counterintuitive approach to yield improvement through drought tolerance. And I say this because at the time, obviously, if you were an industry leader back in the early 2000s and made a lot of money with herbicide resistance technologies or insect tolerance technologies, the next thing a farmer would ask you for is a drought-tolerant crop. And that is where hundreds of millions of dollars went early on in the biotech age. And if you were a leading company then, and you gathered the best scientists at the time, and you were to ask them, what can we do to develop drought-tolerant crops? The consensus approach would have been to identify in nature the adaptations that allow plants, for instance, to survive in desert-like environments. No? If you go to the desert, you can find cacti that can overcome water limitations, and they survive. So maybe they have certain genes that soybeans do not have, and we can transfer these genes through genetic engineering. And that is essentially what they did. They invested hundreds of millions of dollars developing transgenic events that transfer adaptations from plants from extreme environments into sort of the major row crops of agriculture. And you know what they obtained? They obtained plants that could survive with less water but yielded less. And the reason these plants yielded less is because the way plants survive in the desert is by not consuming water. It's by using less water. Cacti don't have leaves, they have thorns, spines, so they don't transpire through stomates. So if you don't consume water, if you don't transpire, you're not performing photosynthesis, right? You're not accumulating sugars. You can survive, but you're not going to yield anymore. You know what Dr. Raquel Chan from the University Nacional of el Litoral in Santa Fe thought at the time? That the way to overcome this complication was not to preserve water in plants, but to cheat them or trick them to think they're not lacking any water, so that they can continue to perform photosynthesis, where their initial response upon a drought event would be to perform a photosynthetic shutdown. So think of this as if you were driving a car and you're about to run out of gas, and the alarm light goes out, and you immediately stop. We all know we can still go for a few more miles, right? Well, plants immediately stop. And the reason they immediately stop is because they prioritize survival to productivity. That makes evolutionary sense, Dobzhansky would say, right? So what Raquel Chan did was bypass that sensory system so that plants would not immediately stop. If things did not revert, these plants will commit suicide, but who cares? I mean, we're buying time so that we can have the next rain event. And you know what happened? That initial technology that we sort of maybe by luck were faced with in 2003, where everyone was very skeptical about the opportunity of drought tolerance research to become sort of a quantum leap in crop productivity, is today the only globally recognized, globally approved solution that works for soybeans and hopefully for wheat. And the business of Bioceres is about bringing this technology to the end users and understanding that non-binary products, products that don't work in a black and white fashion, require a completely different approach to product development. No? These products will perform differently in different environments. Drought tolerance technology gives you a greater benefit in water-limited environments, or when a year is particularly dry, and it probably has no benefit in an otherwise normal year. So technology that has an environmental interaction requires an additional element, which is a prescription tool. Now, we need to know when the technology pays and when it doesn't. We cannot develop broad acre solutions for every single hectare of the country where the environmental conditions of the different hectares will differ depending on where they're located. So the prescription element for non-binary technologies is the gateway to digitalization in agriculture. How are you going to prescribe what a farmer needs if you don't know who the farmer is, where he operates, and you don't have historical data by the meter square of that particular farm? So developing drought tolerance is a way to develop a very meaningful non-binary solution that pays, and is a way to overlap biotech with infotech so that we can go into the next age of agriculture, which from our perspective is in silico agriculture. An agricultural process that can be disintermediated, because of the information platforms that are already creating revolutions in a variety of different verticals, and that we as a company are trying to bring to the market and make a profit in the process. So this is essentially the story of Bioceres, a company designed to infiltrate public research, transform public research in a very capital efficient manner into products that we can commercialize, monetize, and be relevant not just for the Argentine farmers, the Latin American farmers, Latin American community, but the global community involved with capturing photosynthesis with row crops. Sorry for the lack of a presentation. I hope the message was clear, and thank you very much for your attention.